those person, Pratik Bansal, who serves as an application engineer at Integrated Microsystem, a leading technology solution provider in India. Mr. Pratik is involved in advancing simulation and imaging technologies across the country, with a strong focus on enabling the use of Synopsys Symbolware software. Through his role, he supports a wide range of stakeholders, including researchers, academicians, clinicians, and engineers, helping them convert complex 3D image data such as CT and scan data into highly accurate digital models for visualization, simulation, and 3D printing. He works closely with the premium institutions, including IITs, NITs, and AIIMS, Apollo hospitals, effectively bringing the gap between academic research, healthcare, innovation, and industry requirements. His contributions play an important role in ensuring that the Indian institutions gain access to the world class simulation tools and technologies, thereby accelerating research, product development, and smart manufacturing. We are truly delighted to have Mr. Pradeep Bansal with us today.
Over to you, sir.
Thank you so much, ma'am, for a
Okay.
warm welcome. And I'm very thankful to all the participants available here and the conveners and the FDP persons who have organized this FDP and invited me as a resource person. So, my introduction has already been given by Anna Maria ma'am. So, I'm starting with the presentation. So, I'm sharing my screen. I hope my screen is visible to everyone.
Yes, sir. Like screen has been shared.
Okay, okay,
Oh,
okay.
yeah.
Give me 1 second. Okay, so now I think it is visible.
Yes, your
So
screen is
let's
visible.
start. So good evening, everyone. My name is Pratik Bansal, and I'm an application engineer in Integrated Microsystem. So we are the official representatives of Synopsys Simpleware software in India. And today I'm here to discuss about 3D image processing for material modeling and smart additive manufacturing in this FDP titled Predictive AI Models for Route Optimization and Emerging Smart Technologies and Manufacturing 4.0. We'll be seeing the capabilities of the software, for which how it helps in material modeling and smart manufacturing. So let's start. So first discuss about what basically a Synopsys Simpleware software is. So it is a 3D image processing software by which we generate 3D models. We can do finite element analysis. We can do conventional fluid dynamics analysis from the industrial images that are dicond images. So uh, it basically imported dicond data, and as well as it imports raw uh, images that are uh, JPG, PNG, TIFF, and majorly CT scan, micro CT scan, and MRI scans. So it imports the dicon data, and after importing, it basically visualize its 3D reconstruction in this software, and we can also see its 2D view as well as its 3D view. We get this view in the form of slices. So the more number of slices we get, so the more efficient the data will be. After importing, we can do processing, pre-processing, in which we have this crop tool available, we have rescale available, we have resample available. So we can do various kind of pre-processing here. After this, if we want to do any if you want to our data to be cut from any sites, so we can use there are various tools available for that, so we can use this 3D editing tool. Apart from that, we have filtering tools also available if we are working on any data set. And after pre-processing, we move on to the segmentation part. So in this software, we have given three types of segmentation. One is fully manual segmentation by using threshold and other tools. After that, we have this semi-automated segmentation. Then we have fully automated segmentation available here. We have external models also available in the software. So we can do 3D reconstruction of any sample available with us. We can do various sets of simulations like conventional fluid dynamics, finite element modeling. We can do normal porosity analysis also, as well as particle analysis, and many more measurement operations we can perform. Apart from that, we can also do meshing here. There is a major part here. We can do meshing of any sample data we have available with us. Moving forward, uh, what is 3D image processing and why it is necessary here, and how we can get benefit from this Synopsys Simpleware software technology. So basically, we have taken CT dataset of any uh, manufacturing sample. Uh, for example, we have a rock sample. So workflow will be like, we have taken the scan, we will process the dataset. Once the dataset is processed, we will bring it into the simpleware. So we have this three 2D viewers available here with us and one 3D viewer. So we have slices in X, Y, Y, Z, and X, Z axis available in 2D views. Whenever we do a 3D reconstruction of stack of images, it gives us slices in the 2D viewers. And one volume rendering that I've told you, it is a 3D volume rendering available with us. And in the first interface, after importing the dataset, we move on to the pre-processing and then segmentation part. And after that, we move forward into the machine modeling and analysis part. Moving forward to its application areas that are available in this Synopsys Simpleware software, that we can achieve it from this software. So Simpleware software for materials and manufacturing, we have this software for utilization of in this material field, but we have this software available for the applications in medical field as well. Uh, since this session we more focused on manufacturing and materials, so I'll be discussing about additive manufacturing part more. So first we have this complex material modeling. So whenever we are having composite material present with us, the major challenge is to identify different components within the material. How to identify particle fraction, the volume fraction of any specific part that is being present there. So we can solve this complex material modeling using the Synopsys Simpleware. We take a sample, either micro CT, because micro CT image provides us the internal features as well as the external features. So if we are taking any 3D scanner, like if we are working on any 3D scanner, so it will gives only the outer structure, but might not capable enough to give us the internal structure. So we cannot identify any composites available here. So what we can do is we can do multi-phase material reconstruction. So here we identify different sets of material present in our composite material that is being present with us. Once different parts are identified, we create numerous masks. For example, aluminum composite, whatever material present in the aluminum composite will be segmented out as a different mass. Moving forward to digital rock physics. So we have various tools supports us generating this reservoir forecasting data of petrochemical data sets, for example. So Repsol is one of the example that is being used in software to do the reconstruction. So basically the 3D reconstruction of any rock sample. Moving forward to the non-destructing evaluation. So if any part detection, uh, you want to do any additively manufactured part or any part that we need to work on, CT, micro CT dataset, or if we need to do any sort of analysis, that too can be converted using Synopsys simpleware software. So basically it helps us in these all application areas. Moving forward to this inspection and metrology. So basically we provide options to volume rendering here, and we get high quality accuracy in the measurement fields and directly in the volume rendering itself. Moving forward to the reverse engineering that is available here. So to do the reverse engineering, so we have this high value parts available. So we do the modeling of this high value part from image. That too can be done. So we can do the modifications in terms of dimensions, physical aspects, particular phase. All this can be manipulated in Synopsys simpleware software. Even if we induce a conventional fluid, uh, a CAD data set, so with existing data, that too can be do here in Synopsys simpleware software. Moving forward to the additive manufacturing, we can generate watertight STL files, and it can be exported in many formats. For example, NURBS model. So let's move forward. These are the applications of Synopsys simpleware software in materials and manufacturing. So how the workflow is done here in 3D image processing. So first we do the acquisition of our image data set that is present in a DICOM format. So we can say it will be of CT scan, micro CT scan, or MRI scans. So we'll do the acquisition, importing of the data set. After importing, we go for the processing. In the processing, we have this pre-processing available that I've told you that we have this pre-processing tools, crop tool, resample tool, rescale, um, and alignment tool, and we have this padding tool, etc. We have available with this. So after that, we have this segmentation tool available. Uh, how we can achieve the segmentation? We can do open the threshold tool, and in that tool we have a histogram available with us. In that histogram, the data is like the value is measured in house fields unit. So it basically depends on the how much house field unit you are putting there, and that is how you will create a mask out of it. And after creation of the mask, you can go for uh, basically you can go for the color coding here. So color coding in this software can be done by watershed algorithms. So watershed algorithms works inside the inside the software to do as you can see it is the 3D rendering of uh, the metallic foam, and here it has the segmented part available, so it is color coded. So as you can see, it is purple and green and brown. And after that, if you have any quality issues here in your model, you can do the detection, and you can check the segmentation quality, anything you can check here. Many detection tools available here. After that, you can do analysis. I've told you it has post analysis, particle analysis, etc. available here to do the analysis. And we can see the plots of this analysis. After that, if you want to do any diagnosis, that too can be done in the software. So basically, after all, you can visualize your data set. So how it will look like. So after visualizing, you can export the report also. So that is all the workflow of this software. So why image-based modeling is basically necessary? So image-based modeling is like adopted by many technologies here. So in many fields, it is adopted to do the 3D imaging of any we can say surface, any anatomical part, we can say any rock structures or any materials, nanomaterials. So we can see the internal features. For example, if a material have any composites available, so we can achieve that. We can visualize that using this 3D imaging technologies. So it will basically reveal, as I've said you, it will basically reveals the internal features, external as well as internal features. So internal features are uh, more important here in the software, and we can work on industrial and as well as medical data sets, as I've told you. So for medical data sets, we have this DICOM import capability available here, and for the industrial, we have this DICON data set import capabilities. So after this, we have this capabilities of finite element analysis and conventional fluid dynamics analysis to do such kind of simulations here. And it has many export capabilities available to export it into many various FE solvers, CFD solvers. So we can export it as per our need, and we can go for the 3D printing also. So it will basically it is in high demand, and it will allow us to like study the structures, to study the materials according to our need. We can visualize, we can study these. We can do it can be good for research purposes. Moving forward, so how 3D image processing works in different parts. So basically, as I've told you, first we have to just import the data set. So after import, we have this segmentation processing available here. If you are going for the mechanics, then we have this measurement and analysis available here. After everything, we have this model generation available here, and we can also do the 3D image. So basically, import we have done. So after importing, we have this visualization option available. After we have this segmentation, and we can do measurement. And then after model generation, and if we want to do any integration, that too is also done. That too is also done here. So after that, it has also options available in scripting. So we have this log options available here. So we can select all the logs, and we can convert into Python codes to do the automation here. Moving forward to the workflow here. So as we have seen earlier, so image import and visualization is the first part. So this is the first interface of the software after importing. So we have this three 2D viewers and one 3D rendering options available here. 3D volume rendering is available here. So it is a auxetic form. So you are seeing here is the 2D images of this auxetic form, and is the 3D image. So it is available in this XY axis and ZX axis and YZ axis. And it has various kind of tools available here. For image processing, we can go here, and we have other options available. We can drag and drop such mask that we create to do the model generation, to do the analysis. So we have this in we have four types of model generation available here. So we can do surface model generation, we can do finite element model generation, we can do computational fluid dynamics model generation, we can do NURBS model generation, that is non-uniform or rational B-splines. So as I've told you, this is these are the import capabilities available here: MRI, CT scan, micro CT scan, 5SEM, 2D image stacks, raw images, and basically it is a rendering software, so we need a GPU to do such visualizations or rendering. So process will be like image import and visualization, then we have this segmentation processing, then we have this measurement and analysis, then we have CAD and image integration, model generation, and then we have script and automation. Moving forward to the various import formats, it is like given detailed. So we can have like import from DICOM images, DICOM images. Then we have this GIF, JPG, PNG, TIFF. And if you want to import the CAD files, we have this STL, PLY, STEP, IGS. So various kind of import capabilities available here. Moving forward to the workflow. So how the workflow will be here. So basically you can see the segmented part here. It is the color coded part available. So as I've told you, it has three types of segmentation tools available. So first is fully manual segmentation, then we have semi-automated segmentation, then we have fully automated segmentation available. So we can do like fully manual work here to like if you want to now if you are working on a important data set, then you can use various tools available here, and it will help you to accurately segment your data set with the help of manual tools. Moving forward, so it has basically like various like statistics frameworks available here, and we can basically do generate the templates here. We can do like center line creation we can do here. We can also generate the cross-sectional area, cross-sectional lines here, and we can do uh, like like we can uh, generate the metrics of pores analysis, particle analysis. As we have told you that that all can be done with this software. Moving forward, so after this, if you want to upload any CAD file, so we can, it has options available to upload the CAD file. So we can upload the STL file, and we have this IGS and then STEP, and it has also like uh, align options available to align the data set. And we have this landmark registration tools available to basically, if you want to align some data sets to, for example, if we have created a, if we have imported a data set and we want to upload its CAD file also, so we can do use this CAD import options and other landmark registration options to basically align these two, and we can have like we can have the uh, basically uh, very efficient data and metrics it will give to us with the help of landmark registration, and we can import such kind of files. Moving forward to the topology and observing smoothing. So we have this various kind of filters available here. So as as well as in model generation, we have some filters available. We can do basically we can do the in additive manufacturing we can do the watertight STL uh, multi-part surfaces. So we can do the watertight analysis here, and we can do basically if we are working on additive manufacturing, so it has supported tools available here. We can use the it has uh, one tool to generate the mesh uh, mesh quality generation, segmentation quality generation, and it has one tool named uh, mask mask similarity calculator. So basically we can do such kind of analysis here. We can do such kind of operations with these tools, and we can set, if we are working on model generation, we can set the coarseness values. We have this mesh quality generation tool. We can fix this if we found any effect in our mesh quality, we can fix with single operations. So everything in the software works in single click operations. So we don't have to do any complex operations here. Moving forward to the export formats, first we have like studied about the import formats. Then it has the export formats available here. So it has export formats in ANSYS, Abacus, LS-DYNA, and then we have this VTK available here, console, Astran. So for different kind of models. So if you're working on FE model, so it has Abacus, Adina, ANSYS, LS-DYNA. If you're working on CFD, so these are the basically solvers of FE, CFD, knobs. So you can directly export it into that. It has one more feature available here, that is direct integration with SolidWorks. So it can directly integrate it with SolidWorks to its import and export capabilities. So it will remove the manual work to importing and exporting. It can work with the integration. Moving forward to the workflow, how the workflow will be done here of scripting. So when we talk about scripting, so it has log tools available here. So in the log tools, we have whatever we do. So whatever we do, like from importing the data set to doing other operations, we can convert it into Python code, and we can run this to automate our process. If we are working on if we are working on similar data sets every time, so it can like reduce the manual process, and it will automate your segmentation work, or if you talk about any other modeling or something analysis, so it can automate any kind of work. So it has this API generation available also. It has this macro record option available here. So this you are showing this you are seeing is converting log to script. So we are converting the log. So this we are doing. So apart from that, it has like we can uh, use the plugins here, and basically it will fully automate the process. As you can see here, these are the users of Synopsys Simpleware in India. We have users in AIMS, IIT Delhi, CSIR, DRDO, IIT Bombay, and various institutions. So we can see the live demonstration of this 3D image processing using Synopsys Simpleware software. Whatever we have seen in the presentation, we're now going to see in the software. So let me just start the software. I think there is some issue with the license. Since cannot fetch the license right now, so I have one video available for it. You get to know the capabilities of the software with this video. Hmm.
Moving to data set, we'll be seeing various kind of on it from here also. So initial window, we have food data set, that is means by we have cylinder generation also. So we'll see that. So I'm opening my software. I can open it from here also. So I'll type simpleware. This is the starting window of Synopsys simpleware. So as you can see here, this is your initial window. You will see after opening this software, you can see the GUI. So it has many like various ribbons available. For example, it is image processing available, in which you can achieve manual segmentation as well as the processing of the segmented image. As I was talking about, you can use this in pre-processing also. So for the pre-processing, you have this resample tool, crop tool, rescale tool, shrink wrap, padding, align, register datasets, and various tools in advance. We have this threshold for the manual segmentation. We have multi-level O2 segmentation in the advance here also. We can use this mask slut fill to like reduce any noise and artifacts and like only keep the largest island. We have this additional filters option available like bone filling filter, fill gaps, and we have smoothing filters also. So let's import a dataset. So I'll be going to Windows C, program files. Then we have Synopsys. Then we have Synopsys simpleware, the version X2025.06. In the data, we have this all the data sets available. So I'll be using the auxetic form. So I have this auxetic form or data set available, in which I have segmented also, and I have only the imported one. So I'll be using this imported one. So as you have seen this in the presentation also. So this is the 3D volume rendering that you're seeing here, and 3 2D views, and you can see this. These are the slices. So total number of slices here are 100. These are the axes, and here you are getting the project information. So we are going to work mostly on the 3D dataset. It is your choice to work on 2D dataset or like fully on 3D dataset, or you can work like combinedly. So I'm opening or expanding this. So this is our dataset. As you can see, it is like too blurry to see. I'll be going into the threshold. I'll be selecting the lower value. Here it is the histogram. I can like on the basis of grayscales, I can do the thresholding of this and generate the mask out of it. So I'll be using the lower value of 40 and the upper value of 255. I won't be using this additional processing of fill cavities in the resulting mask, or only keep the largest resultant. I don't need this now. So I will apply on this all slices, and the output is new mask. So the mask I have generated. So to see the mask, I have to click on this generate a fast preview. So this is like from fast preview, you don't like consider it as a low quality. It has the high quality preview. So it is on set it on the 10. So it is the high quality preview. So I'll click on this generate on the fast preview. So as you can see, it has created a mask out of it. So this is our exotic form. You can achieve the same operation. For example, import. You can achieve the same operation with the help of this multi-level auto segmentation. For example, I'm opening this, going into Windows C, then program files, synopsis, simpleware data, and then the exotic form. Imported, open. So after this, I'll go into this image processing. Let's expand this. So from image processing, I'll go into this advanced, and here we have this multi-level auto segmentation. So I'll click on this. The number of masks I have to generate, like for example, it has selected on 3, you can click on 5th. So any number of masks you can generate. So that is how that is efficiently it has created out the 3 masks out of this. So let's see, currently these 3 are open. So after the multi-level auto segmentation, you can see this is your image looks like. So let's remove the air. So after removing the air, you can see these are the masks you have generated. After removing these 2, you get the final product here. And you can go into additional processing, like for example, you can go into bone filling. So currently Utsu 3 is selected. So I'll click on apply. So it will fill any any bone that is like hollow from inside, or any like structure that is on non-uniform. After this, let's click on this. So it has generated the full, like it has captured the full air. So that is how you can achieve this. So you can achieve all the other operations from here, like you can achieve fill gaps, cavity fill, and you have recursive Gaussian, and all the other things, like you have local surface correction options available also. From here you have multiple viewing options available here. So for example, if I go into this enable and basically if I okay. So if I do this, so as you can see, you can see like any internal structure from this, and you can achieve the same from this in the surface tools. We have this internal structure wizard. So for that you have to generate into the mask to surface. So currently it is a mask. So after generation, let's like first disable it. So in the surface tools, like now if you go into basically internal structure wizard, and then next you can like set the shell value, coarseness values, and cavities value from here, and other modifications available. Okay, so it has given me some error. Let's wait for it. So I'm opening the data set again. For this time I'm opening the segmented data set. I'm going to data, auxetic form, and then segmented. Let's open this. Expand this, and I just have to click on this generate a fast preview. So as you can see, it has already been segmented. So from you, I was showing you this. Wait. So you can achieve these operations from here. Even if anytime you want digital X-ray, that can be achievable from here. Disable. And even if you want to go into these measurements to like do any measurement operations, for example, if I want to create center lines out of it, so currently it is selected, so I'll go into create center lines. So I can create center lines from here. Even if I want to do the quick line statistics, I want to see the cross-sectional area here. You can see the cross-sectional area here. So I can achieve like various operations from these tool ribbon available. I'm opening another example. For example, after exotic form, let's open this manifold. I'm opening manifold CFD. So as you can see, these are the 3 2D viewers, and this is your volume rendering. Currently it is the volume rendering only. So we're going to segment it out since it is looking like really clean data. So we just have to like click on the segmentation. So it has created me the mask. I just have to click on generate a fast preview. So it has captured volume, air. So first we remove the air, and then so as you can see, it has generated a manifold. And even after that, if you want to like achieve any operations from here, like if you can see, like here it is not visible. For that I'm opening another example, manifold.sip. So let's open it, and how we can pre-process. So for that, let's go into let's remove this. So as you can see, it has some like basically it has some gaps here that is not available here, but as you can see, some gaps are visible here. So you can achieve that, or you can reduce that from like it has various operations available here to do that. And you can also use this bone fill filter. And same you can achieve it in the 2D viewers. So for example, if any axis do you want to work, you can go into that axis, you can expand that axis, and you can basically correct or like paint there. So it has given us smart paint tool options. So I'll be doing that in a while. So let's so as you can see, it has somehow corrected it. Let's take so I was talking about the pre-processing. So for example, if you are using this crop tool, if you want to remove any part, since all the parts are correct here, since even if you want to remove any part, so you can achieve it from here. So basically okay. And from here you can like change the physical parameters. Currently it is in percentage, you can like put it in the pixel. It is dataset memory of 27 MB. From here you can like upsample or downsample, like to like basically upsample. It will like make the quality of this image higher, and it will and the dataset memory will also go higher. So let's move forward. So let's see how analysis works here. So for example, let's do pore analysis here. After it, let's go into mask. Let's select the template pore size. So as you can see, it has given me all the data set here. I'll click on this run statistics. It will show me the out of date document, so I have to generate a fast preview out of that. Let's just wait for it to complete. So it is almost completed, and you can see the plots in the statistics options here. So the analysis has been successfully completed. So you can see the plots here. So as I was talking about, so these are your analysis plots that you can see, and you can export it also. Moving forward, let's see how model generation works in this synopsis simpleware. So let's take an example of manifold itself, manifold CFD. Let's get it imported. So as you can see, this is our data set. We go into multi-level also segmentation. You can do number of masks, increase the number of masks also. So it has generated me. I'll remove the air. Let's remove the parts also. So it is basically a manifold, and we'll now going to see how we can achieve, since I have isolated this, I'm going to drag and drop this into model. I'm going to see how we can create a CFD model out of it. So for that, it has given me another tool ribbon, and in that I have setup model, and these things will be available in setup model. I have this general option available in this model preview is there, full model generation is there, and segmentation quality. This all we'll see. First we'll go into the setup model. Since I have select the CFD, it has given me all the export formats, and in general it has given me pre-processings, and if I want to do the smart mask smoothing or not. And after that it has given me the plus FE free and plus FE grid options available. So let's like I can't change it here since I'm doing a CFD model generation. I can use this mass density options that is available here. So I can change its coarseness value, for example, and setting it to 30. The more options, I can achieve other modifications here. In the material, it has given me fluid and solid material type. In the boundary conditions, it has given me all to add all the possible boundaries. In the mesh refinement, like it has given me add or manage regions that will open the basically mesh refinement region. So it's like that. And boundary layer, so it has given me also too. So I can click on this to add the boundary layer to the part. So after closing it, I'll click on the segmentation quality to check the segmentation quality of it. Since it is giving me a lot of warnings, I can fix these warnings by just clicking on this fix problems. So all problems have been fixed. So as you have seen, these are the single click operations available. After closing it, I can go into the model preview, and after all, I can go for the full model generation. So as same as the FE, it is showing me 9 steps to create a model out of it. Other than this, we have this is the
So,
starting window of Synopsys Simpleware.
so I hope this Simpleware software is clear to everyone. It is
So
very user-friendly software,
uh,
and its starting window in which we have given us to import start from this new project, or we have it has recommended us such projects we have opened it earlier, and here it has given us the project information. Here it has given us the basically the tool ribbons available. So we have given us with the image processing tool, pre-processing tools, and here we have given us with the segmentation, basically the segmentation tools. So it is for manual segmentation. So if we go advanced here, we'll see multi-level also segmentation that comes under basically semi-automated segmentation. We have this additional tools available here to basically, if we are not satisfied with our mask that we have generated here with the help of threshold, or for example, when we go for a automated segmentation, so we don't need to generate mask, or we don't have to do the thresholding. Since we are doing manual segmentation, we have to do the threshold. So even before thresholding, if you want to like if you want to do any pre-processing, we can do it from here. And after thresholding, if you want to do any filters, like a bone filling filter here, fill gaps filter is available here, island removal is here, smoothing filters is available here, a lot of advanced filters available. So we can basically filter out our data set according to our need, and we can we can get the clean data set before even we segment our data. So for segmentation, it has given us split region tools in which we can split the regions into color coding. So that too is done through watershed algorithm. But when we go for AI tools here, that is auto segmentation, we don't have to do any mask generation or something. We just have to click on auto segmentation. We can click on the data set, and it will generate the data set as per very efficient quality as per our need. But if you want to go, like if you are working on important data set, then we'll go in this manual segmentation going forward. So how we upload the data set? So if you are working on any CT scan, micro CT scan, and MRI scan, so we can basically do not have to import the project itself. So we just go for this Dicon images, and then we have to click on the scan folder option. So it will scan the folder itself, and it will scan out and import the specific CT scan or MRI scan that is available in that folder. So we don't have to import the folder by then. But since we are working on since we have already segmented data sets available here, so we can go into the projects and we can upload the projects directly.
data, we have the
So in this in this interface, we have this 2D viewers available, and this is the volume rendering. So since we are working on auxetic foam right now, here it has given me the project information. Here it has given me the dataset browser, in which if I create the mask out of it, since currently it is the volume rendering only available, if I create the mask, so it will generate a new mask here. And after that, if we drag and drop into models, and if we want to do the analysis, so we just have to click on that specific mask, and we have to just drag and drop into models or analysis to do the modeling or analysis. So this is the threshold that I was talking about. So it basically using the grayscale values, it basically we can set it out on when we are working on auxetic form. The lower value should be, it is recommended to be at 40 and upper value at 255. So we have set these values, and it will like when we generate a preview, it will be a fast preview, but it will be of highest quality. So when we generate, it will generate a mask out of it, and as you can see, it has created a mask one inside a mask folder. And when we want to do modeling or analysis, we just have to drag and drop this active. And when we are working on any operation, any operation, and we use any tool, we just have to click on this to like make it active. And as you can see, it has since we have done the segmentation here, multi-level also segmentation we have done here. Since in this we can create number of masks, and it has since we have created three, so it has given me three segmented part or regions, we can say. So the whole region that is in red, it has captured the air that is available in this region of interest. So we can remove by clicking on this, and we can also remove by isolating any of them. As you can see, it is the segmented part, and and since we get our segmented part, we can work on any like 3D editing if you want to like uh, cut any regions or remove any regions, and we can do filtering also here. And after everything, if you want to work on measurements, like if you want to create center lines here, if you want to create some kind of cross-sectional area or some kind of measurements you want to do, we can achieve it from here. And after that, if you're working on 3D printing, then we can basically uh, know the structures capabilities inside this 3D printing, that how is it capable, it is capable enough for 3D printing or not. So we can achieve it from this 3D printing. And if we are going for model generation, we can just drag and drop, and in 9 steps it will complete it. Since everything here, it will be done within uh, one or two single clicks, 1 or 2 clicks. So it is very user friendly software, and we can achieve modeling from here. We can achieve analysis from here. We can go for 3D printing of any material. And as you have seen, the processing is very high since we are working on 3D image data sets. So it needs some processing time. It needs some processing time. But in the simpler software, it is very optimized so that we don't have to sit for hours working in this software. We can work directly, and anything, if any operation is running, any simulation is running, it will be very quick. And the quality, as you've seen, this is a highest quality that it can give. And if you want to like make it our data set more efficient, we have this resample tool available here to upsample or downsample our images. We have this crop tool available to shorten our region of interest. We have this padding shrink ramp available to basically uniformly increase or decrease the region of interest. We have this align. So if we are working on two masks, so we can align the data sets from here. So we can do various operations. Here we can do the analysis. Since we have opened only pore analysis here. So first we have to load the template, and then we can run the analysis. We can see the plots out of here. So as you can see, these are the plots, and there are various kind of plots that you can see: throat elongation histogram, pore shape factor histogram. So you can see various plots here. If you go for model generation, it gives us various tools and various modifications to do, and it also like generate segmentation quality and fix the quality in single clicks. After model preview, we can go for full model generation. It will create a mesh out of it. So that is all from my side. This is my contact details for any queries. If you have, you can ask, or if you want to drop any queries, you can drop it here. This is my number and email. You can call me anytime.
Excuse me, sir. Hello.
Hello, 1 second. Yes, sir.
Yeah, I'm audible, sir.
Hello.
Yeah, I'm audible, sir. Hello.
Hello.
Yes,
Yes,
sir, you
please.
are
Can
audible.
you speak? Yes.
Okay.
Oh.
Sir, I joined lately. Sorry for that. This tool can be used for two-dimensional images also, na, sir?
Uh, hello. Can you speak a little bit louder, please?
This tool can be used for two-dimensional images also, na, sir?
Yes.
I
So
joined
basically,
lately.
as I've told you, we can import various raw images that in the form of PNG, JPG, and then TIFF, that are all 2D images, and
And
like
one more doubt.
we have this opportunity to upload the 3D scans, so we are uploading 3D scans here.
We can segment multiple labels also, na, on same image, single image.
Yes, sir. We can like segment it has given us it has given us to like it depends on us how on how many regions we want to split it into, and we can segment it. And
That is okay, sir.
I've
But
told you a
I
tool,
am saying multiple
mhm,
labels, multiple labels.
multiple
Number of
levels,
okay, multiple labels with multiple labels.
labels.
Hmm.
Okay,
On
okay.
same image, multiple labels can is it possible using this tool?
Okay. Currently, I'm not understanding your question properly.
Yes.
We can have
In
one
one
discussion
image,
regarding this. Hello.
for example, in one image,
Yes, sir.
one pen and one book is there.
Yes.
So I want to segment a pen and book from
Mm-hmm.
that image. So
Okay.
here I have to give two labels for that. One is pen, one is book.
So basically, you can import the data set. So first you import the book data set, and then you import the pen data set. So you can align that data set also, and you can use it is many uh, integration of like capabilities available. For example, if you are using register datasets tool, so it will basically upload two data sets. For example, one is book and one is pen, and you can do some kind of measurements or some any kind of operation out of it.
No, no, sir, I am not asking that. Suppose one image having multiple labels, meaning multiple different labels.
Okay, different levels.
Uh,
uh,
it is possible to segment those labels on a single image.
okay, from levels, I'm not understanding your point. From levels, we can do we can achieve that I've shown you in this software. We can achieve like we can achieve some operations. We can achieve various operations here in various it is, since it is a 3D image, so we can achieve it from like any point of angle, or any angle we can achieve
Mm.
the segmentation. Or if you are going for measurements, that too can be done.
What I am asking is, suppose I
Mhm.
uploaded one image,
Yes, sir. Yes, sir.
2D image. In that
Okay.
image, suppose that image having different types of fruits. Suppose apple, banana. I
Mm-hmm.
want to segment separately those. Suppose some apples are there, some bananas are there.
Okay.
So I have to give one label for banana and another label for apple.
Okay.
So on single image, is it possible using this tool?
For like you can achieve it, but since when you are doing pre-processing, it will ask you to like if it will ask you to uh, keep on the region of interest. Since you are working on banana, so it will remove other island from it. So
Oh,
so if you want to work on it, so you have to like use the register datasets or the other import capabilities to like work simultaneously on both of them.
okay,
So
okay, sir.
then it will segment out.
Mhm. Okay, okay, sir. Okay,
Yes.
thank
Thank you so much, sir.
okay, thank you.
Pratik, sir, okay. Just for the proof purpose, we require the image. Okay, thank you, sir.
Yes, sir. So that
Good
is
evening,
all from
sir.
my side. I'm sharing my contact details again. If anyone want to contact me.
Yeah. Okay,
Good
thank
evening,
you.
sir.
Thank you so much, sir. Okay, somebody's
Excuse
having
me.
query. Yeah, yes, ma'am.
Yeah.
Continue.
Good evening, sir. This is Dr. Asha Vijay.
Okay.
Actually, like first time I'm seeing this kind of software, so I just want to know, like, if there is a video to practice this or something like that.
Can you please repeat again?
Sir, if there is a video or something through
Uh-huh.
which we can practice this kind of software and the data, so that we can further get
Yes,
extra
yes,
time
yes,
of this
yes, yes.
particular software.
Yes, yes, yes. So since we also do the sessions, we do the demonstration, personal demonstration also of this software. You can try the we give 1 month evaluation license for it. You can try the software. You can work on it. If you have any data sets, if you have any data set available with you, you can work on that with the like 1 month we give it for you. Since it is a proprietary software, so after that you have to buy the license of it. Uh, as I've told you, it is very user-friendly software, and uh, you will
Sir,
get
in
a
that case,
lot of
we have to contact you only, or is there any other link or something officially to contact them?
Since in India we are only dealing with this software, so we are the only representative of Synopsys Simpleware in India. So we are so I'm working as a technical as well as the salesperson here. So I'm dealing the Synopsys Simpleware in this company. So you can contact me directly, and if anything from your side is positive, we can have one online demonstration also. We can give you evaluation license in which you can try that software on your own, and you can work on that software. We can provide you recorded sessions also, videos also, if you are stuck in somewhere, so you can use that videos to like work on this software.
Okay, sir. Thank you. It was a really
Yes, sir.
wonderful session.
Yes. Yes, ma'am. Yes, ma'am. Thank you so much, ma'am.
So one question, sir, is it a free software?
No, ma'am. It is a
Okay.
proprietary software. So if you go for full bundle that I've shown you with all the AI features, with all the modeling features, with all the other features for research for academicians, since we give the software to IITs and ITs and other institutions. So for academicians, it will cost you around for full bundle. If you go for full bundle, it will cost you around 8 lakhs plus GST for single year license. And if you go for a permanent license, perpetual license, so it will cost you around 24 lakhs plus GST. And if you want to work on like we have this scan IP version is also available here. So it will cost you around something around 6 lakhs plus GST. And the scan IP perpetual is of around 14 lakhs plus GST. So that is how you can utilize the software. And 1 month we can give you for the evaluation. That is for free. And you can work on this software.
Another question in the chat, sir, is it completely related to engineering field like inclusive of medical manufacturing, or is there way to map it with the management field?
Okay. So basically, majorly it depends on majorly it is on the engineering level. Since if we are working on some kind of materials, some kind of rock sample, some kind of like parts of some machinery, so it can work in that way. And it has applications in medical field also. So we can visualize and we can study how, like we can study the surgeries, virtual surgeries here. And we can work on various anatomical structures. We can basically segment it and model it. So basically, majorly the software helps the pediatric cardiologist to basically 3D print the heart and to know the VSD and other diseases in it. It has applications in materials and manufacturing. So this session was totally like for the materials and manufacturing field. So I've shown you the materials only, and I've not shown you any medical related. On medical part, it is very vast. It comes in medical, like specifically for medical, it comes in Simpleware Medical software in the name of Simple Medical software. Yes, ma'am. So that is all from my side.
Yes, sir. Thank you so much, sir. Thank you for showing the demo. I believe that it would have helped the participants understand better.
Yes,
So
ma'am.
thank you. It was really informative session, sir. Thank
Thank
you
you so
once
much,
again.
ma'am.
Thank you,
Thank
sir.
you so much.
Thank you. Ayush, sir, are you available? Have you joined?
Yes, ma'am, I have joined. I'm audible?
Yes, 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 sir.
Sure.
I'll make you co-host. Anna, are you there?
Yes, ma'am. So thank you so much, Mr. Pratik Bansal. It's my privilege to introduce our second distinguished resource person, Mr. Ayush Singh, who is a business development manager at Immersive MedTech Solutions. Mr. Ayush leads initiatives in the area of medical imaging, extended reality, and immersive visualization technologies across India. He's closely associated with the promotion of Elusis by Realize Medical, a powerful VR-based platform that enables the transformation of 2D and 3D medical imaging data into interactive and immersive 3D models for enhanced visualization, planning, training, and collaborative decision making. Through his work, Mr. Ayush collaborates with leading healthcare and academic institutions such as AIIMS, Apollo Hospitals, and Medanta. His efforts contribute significantly towards integrating next generation visualization and AI driven technologies into practical application, improving both learning experiences and real world outcomes. We are pleased to have you, sir.
Thank you very much, ma'am, for a warm welcome. I sincerely appreciate the opportunity to present the software and to discuss how the VR segmentation and basically virtual reality is playing the role in smart manufacturing. So I'm just sharing my screen. Just let me know if it's visible. I hope
Yes,
my
it's
screen is
visible.
visible.
Yes, sir. It's
visible.
Sure. Yeah, so I'll just directly start up with the presentation. So what I'll try to do is I'll also try to demonstrate how we can basically use VR headset, but the battery of VR headset is quite low, so I'm just kept it on charging. If it gets completed, so I'll just later on show a live demonstration. Otherwise, I have a recorded session of the same. After my presentation, I will be showing the presentation if the VR headset doesn't work in that case. So without wasting much time, as ma'am has already introduced, and thank you very much, ma'am, for warm introduction. So myself, Ayush, I am a business development manager at Immersive MedTech Solutions. So my core role is to basically sell out software solutions to the market that are directly capable and impacting the human lives. So the current software that I'm dealing with is Elusis by Realize Medical. Apart from this, I have another 8 to 10 softwares that ranges for various sets of application, like for any ADA development, that is electronic development and automation for semiconductor industries. We have certain tools. Then we have for quantum ETK, that is for nanomaterial and device level modeling. That is also smart manufacturing part to develop of materials as well as for developing of devices at a nano level. Then coming up after that, we have this Elosus by Realize Medical that plays a crucial role in revolutionizing the particular VR-based segmentation techniques and various other sets of algorithms to have the use of automated segmentation, that is AI-enabled segmentation techniques to basically build on data set to convert out the existing data set into high fidelity models that can be easily interpreted and can be worked on. So without wasting much time, I'll just give a brief introduction about what is Elusis and how it is basically playing a role. Uh, so let me just give a second. My laptop's hanging a bit. Yeah. I'll just stop the sharing for a second. Screen. Yeah. So before that, I'll just brief up about how the particular field has been evolved from old segmentation techniques that used to have manual 2D based image tracings. So for decades, whether in medical imaging or industrial non-destructive testing, we have faced a bottleneck. We captured the 3D data like CTs, that is computed tomographies, then MRIs, magnetic resonance imaging, or LiDAR-based images, but we didn't have any option to basically visualize in a 3D view. We used to rely on the 2D screens. This not only forced our brain to do heavy lifting, like mentally reconstructing a 3D object from flat slices, it also created a massive cognitive load, which ultimately resulted in slow, fatigue, and prone to error-based methods. So, to cover out this particular, there was a wide gap in the market. Then came in the picture Elusis software. So here is the point where Elusis has played a crucial role, and it has changed. So it is the world's first fully immersive VR-based platform for segmentation and modeling. Its core philosophy is just very simple. Don't just view the data, step inside the data, just check how the particular data is interacting, check between the slices of images. We can model multiple different parts from a single slice of data set. So even if we are having a single slice of data set and it has multiple objects, so we can easily distinguish out different objects. We can do the particular labeling and segmentation accordingly. And then whichever part is of our region of interest, we can just create that part and remove out the particular part that is not lies in our region of interest. So this way, whatever process that we were having in the earlier steps, like to do manual based segmentation, to do manual based modeling, all get reduced, as now we can directly go inside the image dataset. Once we have gone inside the image dataset, we can directly carry out and start doing the segmentation. When the parts are segmentized, we not only do the particular model making, but we are also accompanied with various measurement techniques. So measurement techniques like point-to-point measurement, then we have angle measurement, then we have fatigue measurement, any stress measurement, wall thickness measurement. So there are different sets of measurement tools that are accompanied inside our software. How we overcome any challenges that we face? It's quite simple when we are working with VR. We can directly go to the specific point of interest. we have all the particular 6 degrees of freedom to roam around the data set. So we do not only miss any single feature that is of important for us. Apart from that, it is also very crucial to understand the data set. Even if we have multiple data sets with us, if we don't have proper visualization techniques or proper processing techniques, it's of no use. It's like dead data set for us. To have it implemented in a virtual environment, in a predictive environment, to be honest. So we train out data sets, we train out AI-based algorithms to do work for us, and we need to have trained data set for that particular case. Now, why VR for segmentation? So it's basically very easy answer for that. We used to have different segmentation techniques, like we used to rely on 2D based segmentation, wherein any object that we had city images, we have micro city images, but whenever we loaded the data set, what we were trying to do is we were trying to visualize any 3D data set in a 2D view. Since our display screen, like for example, a laptop or desktop, is all 2D view. So what we had is either we had the axial direction, we have the vertical, then YZ corresponds to coronal, and XZ corresponds to sagittal view. I hope my voice is clear because there's some disturbance in my Wi-Fi data set.
Yeah,
So
it's
sorry for
clear
that.
now. In between, there was a small problem. Otherwise, it's okay, sir. You can continue.
Sure. So sorry for that. So I'm just continuing to my point. So apart from the spatial perception, there was also a need to directly work on the data set using all the 6 degrees of freedom. So whenever we are using a VR headset, I'll just also simultaneously switch on my camera to show. So whenever we are working with VR headset, so these are my controllers through which I navigate around the software. And this is my actual headset that we just plug in and while we are using the software. So what we do have is these are our hands. Whatever process that we need to do, we need to start doing the particular process using the controller. So we have different buttons inside the controllers for a specified set of purposes. Whenever we are working around the data set, you can see I can move my hand in any direction. So we aren't restricted Apart from that, we have more natural than 2D mouse interaction. Accessing the data set, we can also use our hands. So we can just directly work with our hands. We can navigate around the data set. There are different sets of steps that can be further done. And it is not just limited to medical image data set. Since the software is much more prioritized on the medical image data set, that's why we tend to say about it. But nonetheless, apart from medical image data set, we are having any industrial image data set. Like for example, if we have a city example of a rock and we need to do any sort of oil sample analysis from it. So it comes as a part of smart manufacturing, wherein we optimize the task. So we take multiple sets of examples for a single data set. And once we have a large chunk of data set, what we do is we try to find the most optimized solution to extract out the valuable resource from that. The best way is to directly go inside the dataset to find out our exact requirement points and then to do the particular sets of measurement. So even the software is focused for the medical image dataset. I had worked on certain rock samples. I had done work on certain porous aluminum materials, then some auxetic forms that we have worked on. So there are different sets of materials that can be reverse engineered. Then we can have our own set of lattice structure creation. So here we have all the particular 6 degrees of freedom. So we can insert in any STL file. We can do the particular modification. STL file is basically stereolithography file. So whenever we are saying or hearing the term additive manufacturing, so there is a term called STL because majority of the particular 3D printed files either come in a form of STL or .obj files, .ply files, .step files, .igs files. So these are different formats of the 3D printing support. Then we also have the 3MF format, that is direct readable 3D printing format for us. So this way we can easily navigate the data set. We can just work around the data set. and thus have much more better interaction as compared to the earlier versions. Now, how we are basically bridging the gap to smart manufacturing. So now how does a medical software fit into this FDP? So this is the critical link. The techniques we use to segment a human bone are identical to the techniques that are used to segment a porous engine block or design a complex lattice for aerospace. So whether it is a biomanufacturing or industrial design, digital twins, the workflow is the same. So what we have in the workflow is first we scan the data set. Once we have got the scanned data set, we segment out the data set, then we model out the data set, and then we do the prediction, how the particular model would look, what are the flows in the particular set of models, how the particular file can be optimized for, what are the critical points that we need to keep in mind while we are doing the actual manufacturing. So for example, we have done a particular designing, and the next part while we have done the designing is to check and fit the particular design into the real world application, which is the most crucial role. And this way VR plays a very key gap, key bridge between this particular gap. So what it basically does is we can go to the specific points once some particular measurements and all are done. For example, taking an example of turbine, if it has a small hole, so what it would do is it will decrease the performance, it will decrease the air intake, and ultimately result in bad performance. So what we basically do is we go to the specific point, we fill up the particular region, and then we can further convert out the STL files. Once we got the particular STS dataset from one dataset to another. So for example, we have multiple based image dataset and we need to do the particular overlapping. So that can be done over here. Then comes the biomanufacturing and smart manufacturing part. So it is one such topic that is not discussed when when we are saying about the term biomanufacturing. It not just only includes implants or any specific specific designing. Nowadays, specific processes market is taking a major boom because earlier on, whatever implants and processes that we were having were a generic one, and the main issue with the generic processes or in implants is it has wear and tear
So you are not audible,
over
sir.
a period of time, and the wear and tear is wear and tear. Hello, I'm audible now?
Now you are audible, sir. Now you are. But in between, some connection issues are there, it seems.
Yeah, sorry, ma'am. There's some
No,
network
it's
issue at
okay.
my
Yeah,
end.
yeah, the technical glitches will come. No problem. So you continue.
Sure. Yeah, pardon for the network issues. So I'm just continuing why we are requiring the particular biomanufacturing and smart manufacturing. So what I'm trying to say is, whenever we are dealing with any particular patient-specific implant design or patient-specific prosthesis design, earlier on, what we used to have is we used to have a generic one. So the main cause of the main issue that we faced with a generic one was it had wear and tear over a period of time, which resulted in patient discomfort, and ultimately there was a need to again and again reconstruct the particular implants to be fit in, which involved multiple surgeries for a single process. So now using this biomanufacturing parts like VR based segmentation, we can go to the specific point, then we can design the particular implants according to every different anatomy. So every patient has different anatomy, so the particular design can be created directly in the VR headset using a free design tool that is present in the software itself. And this way the particular patient can have better implants, and thus increases our outcome level. And not just that, when we are dealing with any particular is very much easy, but to design in a 2D is quite difficult. because we have to consider all the particular axes. And basically, we are visualizing the data set in 2D. So, for example, even if it's a cuboid, we are still having the outlines in the 2D. So the dimensions are not very much clear. But when we work in 3D, so we have the liberty to go in the other direction also, other dimension also, to check for its accuracy, which I'll further show in my live demo how we do that. Now comes the interface. So it looks like a sci-fi movie, but this is for real once we are working with any virtual reality software. I'm not just stating out this is, but any virtual reality software or even the Meta Quest headset. So this is the Meta Quest headset that I generally use. So it's a Quest 2 by Meta. It's a very good headset and it has quite precise accuracy. It has quite good optimization, and it's not just limited for one software. We can do endless tasks. So even if someone wants to just have fun, watch any VR-based movies, so it's much more greater than any 3D movie when we are visualizing. So that too can be covered. Then, for example, any particular video that needs to be checked, so it can all be done on a Quest 2 or any other Meta headset, any other VR headset that we are working. Whenever we are inside the headset, so this is how our general overview looks like. Either we can use the controllers as I had earlier shown, or we can use our hands to basically navigate between the dataset. So it's a free view. We can increase, decrease size, we can move it further to us, we can bring it closer to us. Then to optimize any specific particular part, that too can be done. And the optimization is quite seamless. We can move from one page to another. We can have multiple interface open in front of us. So we can do multitasking at an ease. Once we are inside the Edoso software for doing any segmentation or any analysis based task, what we have is we'll get similar windows. We can open multiple windows in a single view. We can navigate between different works. Then we have a particular palette. So what this particular palette does is it gives us numerous controls, like to model the particular surface, to do free designing. Apart from that, we have various options of growing. Then in the tools, we have the cutting planes and 3D slicers, so we can do multiplanar reconstruction of any object that we are having. So we aren't just limited to medical data set. Even if there's a rock sample or any other manufactured part we need to do the resampling for, can be done in a very easy way. Then we have the direct 3D segmentation. So what we are doing is we are directly tracing down the particular anatomical structure in the ear itself. So what we generally say to such softwares is they are like sculpting software. So we have our sculptor in our hands, and we are the sculptor, and we just can design any object just on our imagination basis. So even if we are dealing with any patient specific data set, we have modeled a particular part. We need to do particular sets of tracing directly in the air that can be done. Then we have the options of capturing non-planar region of interest also. We can cut along the slices to visualize any specific part, any specific defect. For example, if since I am much more familiar with the medical terms, so I'll just state one medical term, that is DORB. So if any data set is having a DORB, for a surgeon to plan any surgery, it's much more important to know the exact outlets, exact inlets, then the particular porosity structures, the particular connections. And once that is done, the particular cut section is created and we can just visualize the internal structure. And it is impossible to capture in the traditional 2D views, because whenever we are working with any 2D traditional 2D view, it only captures the one direction, and rest two views are basically ignored out. So this way, the particular VR plays an important role. Next comes are the assisted different sets of segmentation tools. So then we have the region growing. So for example, we have designed a particular set of region, but the next part that we need to have is we need to basically grow the region from a specific point. So there are different sets of features like seed point feature or directly growing feature, from which we can directly select a specific point. So I'll just select auto pointer. So for example, this is the particular point. We have selected this point, and through this particular point, we will just increase our surface, and it will slowly on the basis of grayscale value. So what we can say a grayscale value in simple naive terms is that it's a basically visualization of image on the basis of bits. So the more darker region corresponds to more uh, zeroed scale, and the brighter region corresponds to 255. So different set of images have different set of grayscale value through which we can do the particular sets of modeling. So on the basis of a smart grayscale visualization using various automated algorithms, we define a region and it expands automatically. So for example, if we are focused on lungs, we just need to define a single part in lung, and when the particular set point is defined, we can easily grow out the region on the basis of our strength that is required. The next part is the most important one. Whenever we are particularly drawing and sculpting in the VR view, we need to have the efficient use of tools like painting and erasing, so we can easily paint out different regions that are present in any environment. And similarly, we can just reduce down any specific point that isn't required. This is also very much helpful in identifying any medical defects, like for a tumor detection or cancerous cell detection. We can easily highlight that on the basis of grayscale range. And furthermore, the surgeon will get the specific point of interest, at what point particular work needs to be done and needs to be removed. The next step is a very important role that we have. So we have a real-time VR collaboration. So for example, if particular one radiologist is sitting in Dubai and another one is sitting in New Delhi, so they can come down in a single virtual environment and do the collaboration. They can give their inputs. They can also do the particulars segmentation. So we have the global co-editing of models. And you're in any part of world, you can come in the single virtual environment, discuss up the cases, discuss up the designs, not for the particular surgery one, but even if we are doing any smart manufacturing, we have designed and we need to get it checked by some team sitting in Japan. So what we can do is we can directly call them in our virtual environment. Once we have checked on the designs, they can highlight the specific point of interest that we checked for. And once this all is done, we can be satisfied. We can also annotate between the models. We can use voice memos. So there are multiple parts that can be covered out. The next part is the cross-sectional analysis. So we don't just discard the basics. You can grab a cutting plane and slice through the model dynamically. It is very vital for inspecting internal porosity or verifying wall thickness in the case of additive manufacturing. So for example, if we need to focus on a hypothalamus, so we can take the particular range sectional, and then the particular cross-section, two-dimensional cross-sectional view can be created, so that whatever model that we are making in VR, we need to have to check its accuracy in the virtual view as well. So for that, this particular cross-sectional analysis plays a crucial role. We can identify different parts, and even if we are doing any sort of porosity analysis or any defect analysis, we can go to the specific point. For example, this has some surface area, so it can be calculated, its volume can be calculated out. Corresponding to which position it is, we can identify the position. So whenever we are working in VR view, it corresponds the data set into 3 points, that is x coordinate, y coordinate, and z coordinate, followed by the grayscale value of the specific point. So supposedly this is our pointer and it has x, y, z coordinate as 10, 20, and 30, and the grayscale value is around 1400. So it will highlight the particular points so that we can do precise point level to point level measurement. So there is no set of any distortion in whatever results that we are producing. The next step is a very much important part, that is 3D sketching and design. So for example, if this is a femur that we're working, if we need to draw any guides, fixtures directly on anatomy, so now that can be done. We can just slice around the data set. We can do the particular set of designing. So Pelosis goes just beyond segmentation. It also allows us for doing the particular designing. And not just this particular support structures and all. We have full set of surface development tools. So for example, even if we are designing any cranial implant, that can be done. Or example, if we are designing any fittings inside an engine, so that too can be designed freely inside the VR view. Then next up, we have the export capabilities. So as mentioned earlier, we have majority of exports like STL file, OBJ file, PLY, STEP, IGS, that is initial graphics exchange specification files. And apart from that, we are not just limited to do the particular modeling, exporting for additive manufacturing, that is 3D printing, but we also have is we need to work with finite element analysis and then use it for doing the particular 3D printing. So we can easily check out the particular thickness value. We can check out any set of, for example, bone sample that we are working. So we can check out bone density, and later on the particular thing can be exported out for doing the particular 3D printing. The 3D printing plays a crucial role whenever we are identifying the object. So I do have one such example of a 3D printed model that I created recently. So it's an example of a patient-specific anatomy. I'll just turn on my camera. So this is one such practical application of how the particular after bonding we can do the particular exporting. So you can see there are multiple level of structures that are present. So this is magnetically connected model. So whatever particular planning can be done. So this is one such example uh, where we can easily particularly do the particular modeling. And once the modeling is done, the particular defects and all can be easily identified. And we can have multiple set of slices to be created. And once this particular slice is created, we can do the particular model. One such model I also have apart from medical, but that isn't presented to me right now. So what we can do is even if we are doing complex industrial designing, so that too can be modeled and small prototypes can be created. Once we are working with the prototypes and all, we get familiarization with whatever work we are trying to do. And once we are satisfied with whatever operations that we have performed, we can do the particular export in any sort of views. So apart from this, is the major concern is what are the particular algorithms that we generally use. So for computer scientists in the room under the blood, Elucys manages a hybrid environment. It renders raw voxel, that is volume pixel data set, and generates a polygon mesh in real time. The particular live mesh that we basically produce is what makes the particular interaction so responsive. And once the particular meshing is produced, we can visualize the data set, and it has the real-time meshing. So as soon as we load in the data set, it generates an automated meshing algorithm. And how the particular algorithm was developed, it has developed on the pre-trained data set. So data set is pre-trained on multiple thousands, 10,000s of series of CT scans, MRI scans, and thus the particular ultimate optimization is done to easily render out any data set that we are working on. The next part is to check out the accuracy validation. Since the particular, so the next part is to check out the accuracy validation. So just give me a sec. Yeah. So the next part is to just check the accuracy validation. So since we are doing the faster modeling, so what we need to have is we need to just check out whether whichever data set that we are producing out is a proper data set or not, or what are sorts of errors that can be found out. So it's very simple. We can do a dice score calculation. A dice score is nothing. Whenever we are obtaining an image data set, if we need to correspond it with whatever model that we have produced, we can overlap it with the image data set. And once the particular part is done, we just go and check out the dice score. And the dice score above 0.95 is recommended for a suitable model generation. So this way we can also check out any accuracy of whatever model that we are generating. And then we have the particular gold standard precision. So the particular VR segmentation softwares or VR modeling softwares are now overshadowing the work of the traditional softwares that were present using the 2D and 3D based image segmentation, as the particular process can be done directly. And the time that is reduced is a significant amount of time. We can directly work on large data set in a single frame of time. And in my experience, I have worked on multiple softwares, and the traditional methods used to take around 30 minutes to 40 minutes for a single data set. Now the same time has been reduced down to 2 to 3 minutes. So it's a 10 times faster segmentation. And now we can work with multiple data sets in a less frame of time. So the accuracy has increased, the turnaround time has been reduced. So it's an go and go solutions for in every particular segmentation algorithms. Next up is the particular user experience that we provide in particular LSS software. So UX is built for comfort over here. We have also optimized the frame rates and the interface placement to prevent motion sickness, allowing for long and productive work section. So even if you are putting on headset for couple of hours, you won't face any sort of issue because it's all aligned in a better way to have stable visuals, and it has basically minimized any sensory conflict. So it's quite safer to use, and it's not like the particular would cause any sort of issue. So this way, the particular user experience is quite great. Next up comes the particular security and compliance. So there are various compliance that are required whenever we are working with any smart manufacturing, specifically for medical data sets. So it has already ensured the particular standards or global standards to meet for any patient data sets. It's HIPAA and GDPR certified. Apart from that, we have two sets of segmentation workflows. One is cloud-based segmentation and another being local-based segmentation. So in the local-based segmentation, the data set is stored within the software itself. We need not to send it to the particular server to do the segmentation. But for users who require remote-based segmentation, the following task can also be done. We can send it to cloud data or workflows, and the particular segmentation can be performed at cloud, and the data set can be easily monitored. Then we also have PAC server connectivity, so to keep the confidentiality in mind for any specific data set design that is patented design that needs to be printed out, all is strictly met while we are working with the Elucys, the VR segmentation. So just to give an overview before I start with the live demo, how we do the data set. So we get the particular raw medical imaging input as DICOM dataset and raw industrial image input as DICOM dataset. That is a digital imaging for non-destructive evaluation. And this is DICOM dataset is for medical segmentation. Once it is done, we use the particular VR headset to carry out the segmentation. And this way we carry out and create a digital twin of 2D or 3D dataset that we have done directly in VR. Later on, which can also be exported out for STL and all. So the first and major step whenever we are working with such data set is to use a approach. So the basic approach that is applicable in all the softwares that are available in market is a thresholding based approach. So we parameterize the particular grayscale range, and once the particular grayscale range is parameterized, we identify different regions. So for example, I was hearing one doubt in the last session at last. So for example, there's a pen and there's a cap, and we need to identify different different sets of images within a single image of data set. Yeah, so that can be done. We can easily identify different sets of objects within a single data set and keeping all the particular data set intact. So for example, if we are having a single image of data set and we need to highlight multiple objects, so that can be done. And later on, the particular isolation can be created out. So we can isolate different structures, we can label it accordingly. And once the labeling is done, for example, taking example of pen and its cap, we have segmented the particular parts out. And once the segmentation is completed, we only require the particular pen to be working. So what we can do is we can isolate the particular part out, we can start doing the working, and we can just remove out the region that isn't interested for us. So the next part is the region of interest isolation. So we isolate any specific part that needs to be worked on. Since a data set may comprise of many such parts that isn't required for us for doing the particular segmentation and all. So for that, what we have is we have region of interest isolation. We precisely select the particular target areas and work on the particular segmentation algorithm accordingly. Then next up, we have the particular manual noise and artifact cleanup. So whatever data set that we are particularly comprising of has many metal artifacts. So the CT samples, the micro CT samples are not very clear data samples that we generally get. There are a lot of noises that are being present either due to some sort of interferences or some sort of objects that are underlying over the selected region of interest that needs to be removed and cleaned up before we are starting to do the segmentation. So that is one such case that we work on. And next up, after the particular manual noise artifact cleanup, we obtain the data set. Once the data set has been obtained, we use post-processing operations like smoothing up the particular object for faster processing, faster loading. So there are multiple steps that are required. So yeah, so next step is the particular smoothing and wrapping operation. So we apply for increasing the surface quality. And last up, we have the particular high quality STL, watertight STL files to be created. And once this all parts is done, we have optimized our data for the AI and patient specific implant design. And then we can ultimately integrate it with the various unit models. So there are multiple training data sets for unit models that are available. We basically integrate in a single pipeline, and later on any sort of analysis can be performed in directly. So we have the particular computational fluid dynamics, then finite element analysis that can be directly performed on. And not just that, whenever we are training the particular data sets over any unit model, there is also one important need. Uh, why to build a robust AI model? For example, a unit for automated segmentation, we need a perfect training data set. All Illusis allows experts to rapidly generate the data set on the ground truth data. So we directly import in any patient-specific data. Then we can work on thousands of patient-specific data to basically train using better data sets and equal better predictive models. Specifically in biomanufacturing, we can use this for patient-specific implants. We model the defect in VR and print a titanium part that fits perfectly for the particular patient. Then we also have a route optimization. So whenever we are having a difficulty for finding a path to a specific point, we can do that perfectly in VR. We can just navigate between the points, and we can highlight the particular high impact regions that are present in the particular data set that we are training for. So this is how a particular net can be easily created. A free form of surface mesh can be created. It's very easy to just model. We just need to keep the surface in mind, and the particular model can be created out automatically. Then we have the particular trajectory planning. So this is our point of interest, how to navigate between the particular points. That can be easily done. And for example, in any surgery, to find the path of a tumor without hitting a nerve is a complex routine problem. So by mapping the particular anatomy perfectly in VR, we can simulate and optimize the route before the surgery happens. So it is essentially a GPS for a human body. So we can just navigate to specific points, and then we can just figure out the specific coordinates to be worked on. Now, we can also overlay the data set, that is the registration, as I told earlier, with the image data set that we are working. So we can easily overlay over DICOM images, and when the particular overlaying is done, we can easily map out and control the data set. And whatever we are seeing in VR can be easily exported to do the 3D printing as one such prototype that of heart that I showed earlier. We can model out any specific design that is required for us. Now, this is how the traditional workflow takes place. So it's a very time-consuming process, and the VR-based is a faster and much more digital process. It's very much important to basically optimize any workflow that we are generating out. So overall, quality of results are improved, and the particular there are improvement in the revenue generation because the particular time is basically reduced down. So this plays a crucial role whenever we are doing any sort of business planning. For example, uh, moving trial and error phase into virtual reality, we can drastically reduce the engineering hours and even the material waste. So that saves a crucial amount of time as well as money for us. Then this one is the particular passive viewing. So we just visualize the data set, and this is the live interaction. So apart from the viewing phase, we are also developing such augmented reality based algorithms. So whatever changes that we would be doing, we can map it accordingly with a robot. And so through robotic hands, we can go to the specific points, and the direct interaction can be done. So this is also one such in development phase, which can be rolled out in a couple of years. Then this is how any failure detection can looks like in predictive maintenance. So we can go to specific point, then we can correct out using the particular robotic hands feature. That's very earlier on to predict it, but we are definitely working on that part to have it as robotic arms or whatever controllers that we would add to carry out any sort of failure detection. Now, apart from that, in route optimization, in particular smart factory, we can simulate a factory floor in VR. We can run and route optimization algorithms like automated guided vehicles and watch them and navigate through the virtual space, identify bottlenecks before we lay a single brick. So this is one such options that can be done using VR. Now, the major part is how the particular future roadmap looks like for the particular VR. So looking ahead, we will see a major breakthrough in the XR, that is extended reality pass-through, mixing the real and virtual worlds. And AI can also generate 3D models from single text prompt. So even if we are typing, design me a particular tube with of length and 2 millimeters of diameter. So we just need to type in the text and the AI would automatically generate us the particular STL files. That is also in beta phases in the software, wherein we just need to type in the particular value once the design is created. We just need to require to do the particular modification and nothing more. So this is one such case that the particular future roadmaps looks very promising for the AI. And the key takeaway is whenever we are working with any data set, we need to basically prioritize like solving the particular cognitive load of 2D screens. Then VR is the natural interface for digital twins. And high fidelity VR segmentation is foundation for predictive and accurate AI models. So the elusive software plays a crucial role, specifically in the medical dataset, but is also in the development phase for any sort of material modeling and doing the particular smart manufacturing. So this is up for the particular presentation side. Now I'll just have a live demonstration. Before that, if anyone has any questions, they can let me know. So these are my contact details. This is the QR of our LinkedIn page, so you can follow us over there. I'll just start up with the live demonstration. So give me just 2 minutes. I'm connecting my VR headset. Just allow me a couple of more minutes. I'm just checking the headset.
Okay, sir.
I'm facing some issue with my VR headset, so I'll just play a video out of the software. So it's a pre-recorded session that I recorded earlier. I'm just playing that, and meanwhile, I would be explaining the same. Uh, my face looks like. So here you can see there are two modes of doing the particular segmentation. The first one being the create mode, wherein we can directly go inside any view. We can do all, we are given with all the set of tools, there is no limitation, and we can carry out the particular segmentation later on if we are required to do the modeling and all. So it can be done in the create mode. Then the other mode that we have is the engage mode. So if we are ready with an EEP file, we have already worked on any project in past, and we need to directly open the particular project. So in that case, the particular a project can be directly loaded in. We are limited with some of the features, like we can still do the segmentation and all, but we can just highlight the specific parts. For example, here we can whatever intersection is part is present. So this was a basic segmentation, that was a direct segmentation that was carried out. This is just for engaging, and if someone needs to put up certain points, that can be done. Then if we need to, there are multiple objects, we need to move it in the particular 3D view, that can be carried out. So these are the parts that we have. Then we, if there are multiple users and they need to connect in a single view, so what they can do is they can just click over here and checking. After this checking connection is done, whoever has the same license key can connect and can come in a single window. And once all the particular users are in a single window, they can put their inputs. Apart from this, we are also given with three methods of recording. We can do particular rotational series recording. Here we can set out the field of view, we can select out the rotational axis, and we can check how the particular rotational preview would look like. Once it is done, we can just click on export and we can directly do the rotational image series export. Then if we need to do the whole recording of this particular video. So for example, if we are needed to record the whole session, whatever segmentation part, right from beginning of the DICOM import to segmentation to modeling, we can click on this start video recording and we can start the particular segmentation. Then coming back how to basically work in the particular user software using the create mode, because a create mode is generally required to efficiently work with all the set of tools that are present, and there's no limitations over here. I'll just enable my camera. You can see this is the particular VR headset that I have. Here I'll just connect it. Once we go into, hello, just give me
Yes, sir, you are audible, sir.
a second. Hi, sorry. DICOM image series, that whatever series that we will be having in the particular folder will get scanned in. Then we need to save the particular project as whatever name that we are required for. Before that, this is my left controller that I would be using to control the environment in the over here. So this is the A and B button that I'll be using, and here is the X and Y. Why it is important is because once I'll open it in the particular VR view, what we would be getting is we need to get familiarized with the tool, because if we aren't familiarized with the tool, we won't be able to do the segmentation that efficiently. Apart from that, this particular data set also carries a 4D city image of the same patient. So that's why it takes time for such data sets to be loaded. And once the particular data, all the particular series of the data set has been loaded in, we can bring that in. And here, what other option that we have is, in any software that we generally work on, we can only use one series or two series at max. Here we can choose n number of series. The only restraint that we have is we need to have a powerful hardware for it. Currently, I am working on a remote laptop, so it is not that hardware efficient, but it does the job for me. So it scans the folder. The scanning of folder may take from 2 minutes to 5 minutes, depending on the data set that we are working. For example, if it is a single series of data set, it hardly takes 30 seconds. But if the data set has multiple series within it, so it will take a generally higher amount of time. Once that is done, you might be seeing a small settings tab in the Silosis software. We would need to be going in this particular tab. And once we go over there, what we'll be doing is we will reboot the particular system. So in that case, what it will take is the system would get connected with the particular a VR headset that we are using. And once this is connected, we'll come in a single window in which we need to use the particular software for. So this. Let me open another series meanwhile, since it's taking. So we can Siddhi. First of all, we need to click on this follow point of view. So what the particular follow point of view does is whatever I would be seeing in my VR headset, you would be seeing the same in the screen. So I'll just delete the older segmentation so we can start with the starting. So this is the general view that we get. I'll just click over here, going inside the view. So this is my right controller that I would be using, and this is my left controller. The first and foremost thing that we need to do is we need to click over here in the particular uh, B keystroke in my right controller, and once we click over here, so you can see there are a lot of tabs that are coming in front of us. So what we need to do is the first and foremost thing is we need to click in this configuration. We need to select this quick surface, and once this quick surface is done, we take a 1 hand distance and we select the particular window over here. So what we have an option is we can just click the particular trigger in my left controller and I can hover it around, I can move it in any direction, and we can see the particular data set in any cross section that we are required for. So here we can also rotate it. Here we have another option to increase the size. So even if we need to see it as a larger window, that too can be done. If we need to reduce out the size, that can be done. So it gets fitted in my working window. Then if we need to move it around this particular window without rotating, that can be selected from here. So we have a controller option over here. In this through this controller, I can just select out the outputs. So to get familiarized with the tooltips, we have what we need to do is we need to click on the Y keystroke in the left controller. And once we do that, we need to go inside the settings. And here are tooltips. So once we click on this tooltips, so you will see the magic. So here we have all the options that we are required for. So for example, if we are drawing something, there's the stylus button that is corresponds to the right trigger. Then we have the particular B to open the stylus mode. That is the particular menu that we need to be using. Then we have this navigation window, so we can use navigate around the tools if we need to rotate it along one axis, if we need to rotate it around other axis, that can be done. If we are rotating around central axis, so that can be selected out, and this is the central axis around which the data would be getting rotated. Once we are done with this, if we need to drag and drop it up and down, that can be done. And if I just go and turn my head down, so I can see the data set more clearly in the volume rendering. Coming on to the volume rendering part, so this is one such good feature that we have in Illusis. We can directly go in the particular menu option by clicking the Y keystroke in my left controller, and here we have certain options. So whatever projects that we have worked on in the software gets recorded over here. So at any time we can open any project. Then we have the navigation window. So to move the data set through this particular window, so it can be done over here. We can select out the particular axis, chronological transverse axis. Apart from this, this is the particular clip lane that is initially selected to hover this data set, so that can be selected out, or we can have multiple clip lanes. So even if we need to do multi-planar reconstruction, we can just do it like this, and we can easily do the particular modeling. We can at any time enable and disable it. So this will be much more clear once we do the particular segmentation, how this particular clip lane would act and work for us. So I'm just deleting it for now. Then in the images section, you can see there are a lot of options that we are having. In this particular dataset, there were 3 series of dataset that were loaded. So this is the particular with 40% dilution, then we have 70%, and then we have the 70% for credit. So if we select over here, we can just change the series of dataset that we are working in. And apart from that, what we can do is we can click over it as live image, and here we have a blending option. So there is one primary image and one secondary image on which we work on in this software. Here we can select in and we can blend in the dataset. So this way there will be much more clarity while we are working with the gaps or even at the boundaries, so we can have the most efficient surface to be regenerated. Apart from this, if we are considering the volume rendering, so what we can do is we can click over here and we can generate a volume rendering directly of any part that we need to work on. Here the data set is not very clear, so what we can do is we can, in this option, we can select the part that is required. And even if we are not satisfied with it, what we can do is, so for example, if I select a CT coronary artery, so I can have a much more clear picture of whatever DICOM data set I was working on. So even once the segmentation has been completed and we have worked inside that data set, we can do that easily. Before even doing the segmentation, we can still go to the planes option, and in the planes, we can cut around the plane. So for example, if we need to cut it over here, so that can be done. If I'll just click and add another plane, and I'll just enable this one. So you can see we can how efficiently we can model, and we can cut along the particular axis to see the internals of the surface. So at any point we can cut, we can have multiple planes to be cut out. So we can directly visualize the data set from the DICOM itself. But you can see there is a bit jitter while we are working with such view, because we require around 32 GB of RAM in system while we are working with such data sets. But the current system configuration is around 16 GB. So that's why there is some jittering that is going to occur. So what we have is, for that, we can select over here, and here we can select a ghost mode of operation. Now, whenever we will do up and down for this dataset, it won't jitter, and we can easily work across the dataset. We can do the visualization. Here we can select the points to highlight the specific region. So here we can just model it, and we can select a particular window and level to further see the data set changes. So for example, if it's a soft tissue, I can just highlight over here, and we can select the particular soft tissue. So here we have direct options through which we can select, and we can further work on the data set efficiently. Now the next part comes is the model. So you can see right now the particular structure generation is empty. To start up with the segmentation, what we have is we need to click on this plus sign. Once we click on this plus, so as told, so we have 4 levels of segmentation. One is moderate, one high, ultra, max. We generally prefer using high and ultra max to max, because even at ultra, it will take time to do the segmentation. And high also creates a good and accurate model. So once we do this, we just need to click on create. Here we need to toggle on this both 2D and 3D enable. Now, one might question that nothing has occurred. We have just clicked on it. Yeah. So we haven't done this. We haven't started the segmentation yet. To start the segmentation, we need to click on this A button. Then in the modeling tab, we have the addition option. Here now, what I was showing in the picture in the PPT earlier, here is the image threshold window that we are having. Here is the use threshold add and use threshold subtract. Then here is the one display threshold. What this display threshold does is it will highlight the particular region. So the pink region that you would be seeing, it might be not that clear in the video, but I can pretty clearly see the particular pink region over here that is getting highlighted over. We can select a threshold range, and once that is done, we can start doing the particular sculpting. So if I move my particular pressing my trigger, if I move it forward, so the brush size decreases. If I move it particular backwards, so brush size increases. Similarly, if I change, if I click this left trigger, so the mode of operation changes from addition to subtract. How it happens is, for example, if I'm doing the particular modeling, so I can just click over here, I can select out the parts that I need to model. So we can easily do the particular segmentation. We can increase the brush size to do it a little bit faster. But one might question that there are a lot of nearby regions that are also getting highlighted out. So this is how the particular operation would do once we have generated the particular model. So once we are finished with it, the particular green to orange. And now what we'll do is, whatever part is undesired, we can just remove that out. I'll just reduce out the brush size. I think there's some network issue. Can you see my screen properly? Someone can answer over here. So which we operate inside the data set. So for example, this particular part isn't needed. So I'll just increase the brush size, and I can directly eliminate that particular part out. So we can do the segmentation very efficient way, and it hardly takes around 2 minutes to properly segment out a cardiac anatomy. That's quite difficult while we are working with the traditional approach. So we can easily select out the part that is not required, And the same mode of operation can also be done in a desktop version. So even if we aren't very familiar with the VR headset at once, if we need to do the starting of the software in the particular desktop version, so that too can be done, the segmentation can be carried out. But I generally prefer the VR mode because it's much more time efficient and we can easily do the segmentation. And once we are familiarized with the control, then even if there's any beginner that's using the software for the first time can easily do the segmentation. This is how we can remove out the particular parts, and once the parts have been removed out, and there are multiple methods to segment this particular part from this. So what we can do is we can do a particular shrink operation, and in this particular shrink I can reduce out the noises that are being present in the dataset, and later on while we are growing the aorta, so that can be done. That can be further splitted. So if we need to do a separate segmentation for the particular uh, aorta, so that can also be carried out, and that can be further concluded. So what we do for such cases is we use a AI-based segmentation. So we have AI-enabled segmentation, and once we get a general mapping of the part, we can directly work on it specifically. So here I'll just select out the region, reducing out the precise and mapping it again. So this way it gets mapped, taking out the operation. And this way a particular heart model gets modeled within 2 minutes. It's a very efficient way, and now whatever part is being remaining, for example, the aorta openings, I will just click over here. This way any part can be done. And if I need to reduce out the noises, I can just click on this single click operation. All the small noises that were present gets removed, and later on the other ones that were quite large can be manually be removed from here. I'll just select as operation as remove, selecting operation, selecting the threshold size. Here one more option that we have is, for example, if it's lying in this particular threshold region, I can just select it out, and then if I just change the threshold value over here and I add the particular region, so we can directly model the specific part that is being required. Here it hardly takes some time to do the segmentation. Sorry, I got disconnected. Any soft issue. One more thing that we can do is we can go in the operations, and here we can hollow out the entire structure that we are having. So to do the hollowing of structure, so whenever we are working with a single structure operation, so we have options. So we can duplicate the entire surface. We can expand the surface by some certain extrusion. Then we can do the shelling. Shell means to hollow out the entire surface that we are working on. Then we have smoothing of the particular surface. We can just select it over here, and once the execution has been done, so it will smooth out the entire surface that we are working, and once it is done, we can check the surface over here. Then again, if we need to do the particular hollowing out the structure, we can select out the expansion length. Once it is done, we'll just click on execute. Yeah, now you can see another structure has been generated. Now if I'll go into the model, so there is two surfaces. One is the particular hollow out or hollowing out of this particular heart model that is concluded, and another one being the solid model that we have generated out. Now to see the internal features, what we need to do is we can select out any plane, and once this particular plane has been selected, I will select out this particular plane as one, clicking on it as active, and we can just slide it along, and we can check out the internal of the particular any anatomy that we are working. In this way, any suitable for this. What I'll go is I'll do in this options, and in this structure I would be selecting is this particular shell one. So I'll go into this, clicking shell, splitting, and execute. So it will split up along this particular plane region. Once it is done, once it is done, we'll go into the models, and in the model, so it has further splitted up the part. So I'll just toggle this off. So one part that we have is this one, and then another part that we have is particular this one. So I'll just disable the clip plane. Yeah, so this is one part that we have, and this is the another part that we are having. So this way we can split up it into multiple parts. So for example, if I need to segregate it into 3 different parts, now what I'll do is the particular split operation that I was having, I'll first rename it as 1. I'll just rename it as A. And once I've renamed it as A, now I'll again apply the operation over here. So I'll select out another plane. Yeah, once I've selected this plane, I need to click on the operation, selecting the structure A, further doing the splitting. So this way, what we can do is we can have n number of clip operations and we can split up the different parts. Once this is done, disabling this particular part, and now what we can see is, I'll just delete this also, models, disabling this. So we have 3 structure model in a very less time, so we can easily see the internals of the structure. There's some need to be bonding to be done. So what we'll do is we can go to this active part and then we can apply the region growing operation. So we can just select out the part. Sorry, I'll just undo this operation. I'll select the grow operation instead, selecting a less seeding, reducing out the size, and then slowly we can grow the particular any surface that we are required for. So this way the surface would remain intact and we can do the particular wall marking very efficiently. So this way it can be carried out and we can basically split up different parts. So for example, if I need to visualize only this part to see the internal structure more efficiently, I can go over here, I can see the particular structure, and later on, even if we are required to do the 3D printing of the same, that too can be carried out. Apart from this, we have another sets of operation that comes in the form of design. So design object, currently you will see there is an empty box. So why so? So we have the design object in my right controller. I can select over here. Here you can see there is an option of design. So what we need to do is we need to click on this edit one. Here we need to click on this create. For now, I'm just disabling this also so I can have an empty window. I'll just click over here. So here we also have an option to visualize whatever structures that we are marking in the 2D view or the particular 3D view. We can easily identify and distinguish it out how the particular marking looks like. So this way, any 3D or 2D can be selected out. And here we can also do the movement. So we can select a particular part, we can set it as movable, and then we can move from the active DICOM. So we can create a separate structure for the same. Coming on to the design part, I'll go over here. Since the particular design mode is selected, we can select out the type of surface that we need to design out. So for example, if we are required to design a rectangular prism, so that can be done. We can select out the length and width, and we can select out the depth. And here a particular design can be loaded in. We can also set it manually. So for example, if I require a 55 mm cross 100 mm cross 80 mm rectangular prism, so it can be easily constructed out. And if we are required to be working on this particular, if it's satisfying our needs, so what we can do is we need to click on this converter structure, and it has converted it into this particular structure. Now, if we go into the model, so we can also see the converted design objects over here. We can enable and disable it. Then if we need to do a particular movement, so that can be done, we can set it as movable. And then we can just move it, we can just select it. Once it is selected, we can just move it along the particular axis. So what we need to do is we can just place it anywhere that we are required for along the part. So this is the basic design that we can do. I'll just delete it for now. Apart from this, the best option that I look forward in this is either to create a loop or any tube that we are required. So we can set out a number of control points and we can set out any type of loop that we are required for. Similarly, if we need to remove any point, that can be directly selected out, and any structure can easily be erased too. The best tool is the surface tool. So we can select n number of contact points. Once it is done, we can map out the surface. So even if we are designing for any orthopedic parts, so that can be done. If we need to design baffle, so that can be carried out. We can easily reduce out the dimensions. We can set it out accordingly to the particular surface. So how to do that? I'll go to this particular part. If I need to model it along here, I'll just first delete this particular existing design. So for example, if I need to focus on, let me just remove. I'm just disabling this one also. For example, if I need to design any design for the specific structure, what we can do is we can click on create new surface, and then we can set out a number of control points. So we can have the most precise of the surface to be created out. What we need to do is we just need to add number of couplers. Once the coupling points have been selected out, we can mark it accordingly, and it's 100% correct as we are directly marking it in the 3D view. So we can add one more point. So for example, if this was our required surface, we can just convert it into surface. We can map that out, and we can also, if required, we can change the dimensions. We can reduce out the surface. We can also have follow it out. There are multiple options. Apart from this, we are also having planning tools. For example, if we need to develop any stent, that can be directly selected. We have large number of libraries from which we can do. Once it is done, we need to click on enable, and once it is enabled, we can directly work on this particular part. You can just click over here. Let me, sorry. So in the planning tools, we'll go, we can increase the length, we can increase the width. Then we can also check over here. We can, according to the difference view plane of where we are marking, we can mark it accordingly. And the designing can be directly be carried out. So this is one such approach that we are having. Then we can select any type of selecting the part that we are required for dimensions. And once it is done, we can easily set up. So So this is a general overview of the software that we have, and specifically the designing part that I told over here. So it's a freehand design that we have. So even if we are designing, for example, any tubular structure, so it can be easily designed, and we can select the dimensions, and further on, it can be modeled for any specific requirement. So even apart from medical, if we are doing any sort of material smart manufacturing, so this particular parts can be carried up in. So this is just all an overview from my side. If anyone has any questions till now, please let me know. I am also sharing my contact details for further clearance after the session. So, any questions? I'm just open for the questions.
Participants, you can unmute your mic and ask the questions if you have any, or you can use chat also. Participants, maybe once they start working, they may have more doubts that naturally
Sure,
will come. No, yeah, that only. No, when we see the demo, you will not be able to ask many. Once someone starts using, I think they'll have doubt. And you have shared your number also,
yes, ma'am.
details also. I think maybe they'll contact. Okay.
Sure, ma'am.
Anyone?
Exactly, it's
Yeah.
a new technology, so it's quite
Yes.
difficult to
Yes.
get
Yeah.
a single glance. So once
Yeah.
someone starts working, so they will have a better
Yeah.
idea.
Yes. Now they know. Okay, this is existing. They can use it like this. Okay. So once everyone start using, okay, maybe they'll have more doubt and they'll contact you, sir.
Yeah, definitely, ma'am.
Okay, sir. So
Thank you
thank
so
you
much
so
for
much,
this
sir.
opportunity,
Yeah.
ma'am.
Yeah. Thank you for inviting, like, no, accepting our invitation. And actually, the demonstration was also very, like, no, well presented and easy to follow. So we truly appreciate your effort and the effort you have taken to prepare this presentation and the demo you have shown. Thank you so much, sir. Thank you.
Thank you, ma'am. Thanks for inviting.
Thank you, sir.
Thank you.